Welcome to the next lesson in Math 8. This is Unit 5, Lesson 20, talking about the volume of a sphere. So we're going to explore spheres and their volumes today. The first thing we want to do is talk about if we have to sketch a sphere. One method for that is to simply just draw a full-size circle. And then within that circle, we draw an oval with the back edges. The ones that we can't see are dashed lines. So you can practice sketching some spheres. Sketch a few different sizes. One thing that I would like for you to do here, problem number 2 down below, says to draw a radius and label it R. So we draw a circle, don't judge me. And with that circle, we start at the middle point of that circle between the hemisphere or in the hemisphere line. Think of this as an equator. So if this is the Earth and this is an equator, it's right through the middle. The direct center comes out to the edge or to the edge up at the top, and we see a radius in any direction that we go. You could even take this and take it at an angle, and that's still the exact same radius. So give that a roll. The next section is talking about a sphere in a cylinder. So here's a cone, a sphere, and a cylinder that all have the same radii and the same heights. That's a really cool thing for us because that means that there's a direct connection between all three of them. The radius of the cylinder is 5 units. So we can start by just labeling that radius right here, 5 units. We can also label the radius of the sphere right here, but don't forget the radius of the sphere goes in every single direction. So we'll give a vertical as well, and that means the radius of the cone is also 5 units. The next step is to find the height of the cylinder. The height of the cylinder would be the same as the height of the sphere, and the height of the sphere, if we just go through and double this value, we end up with another radius of 5. So that means the total height of the cylinder must be 10 because the total height of the sphere is 10. So this one, height is equal to 10. Talk about the volume of a cylinder. Here's the formula for volume of a cylinder. Remember that the volume of the cylinder is equal to the area of the base times the height. We're going to leave things in terms of pi. Our radius is 5. Our height is 10. And so we end up getting a value of pi times 25 times 10, which gives us a total volume of 250 times pi units cubed. We should have this one labeled units as well. Don't forget those labels. When we talk about the volume of a cone, we talk about 1/3 the volume of a cylinder. And since these two cylinders or these two figures, the cylinder and the cone, have the exact same height, I can go and label this one as 10 units. And they have the same radius. We know that this cone is exactly 1/3 of this cone, so the cylinder. So the volume should be 1/3 of 250 times pi. So we would say the volume is equal to 250 divided by 3 pi units cubed. There we go. The reason we're not going to a decimal right now is because we're told to give in the values of pi, which means we want exact values, and this would be a repeating decimal that we don't want to play with right now. When we talk about the volume of a sphere, we understand at this point that we learned in the previous lesson that the volume of a cone, the volume of a sphere is 2/3 the volume of a cylinder. So when we set this up, we talk about the volume is equal to 2/3 that of this cylinder, which was 250 pi units, right? So that makes this total volume of 500 thirds pi units to the third power. As we get going into the next problem, we see again a cone, a sphere, and a cylinder that all have the same radii and heights. And we're going to let the radius of the cylinder be r units. So when we talk about this now, we don't have an actual numerical value. We're just saying that this radius is r. Well, that means that this radius right here is also r, and this radius right here is also r. We're going to express our values in terms of pi. And let's see what's next. It says, what is the height of cylinder in terms R? Well, if we're talking about the height of the cylinder in the terms of R, then we're talking about, again, this radius on the sphere is the thing that helps us out. This radius is R as well. For half of the height, the rest of the height is R again. And so what we would recognize with this is based on this height of a sphere that's the same height as a cylinder, we find out that that's twice the radius. Okay, so when we talk about the height in terms of this, the height is going to be 2R units. So in terms of R means that's what we need to have as an R in the value. Okay, so what's the volume of the cylinder in terms of R? Well, if we now know the height and we now know the radius, what we can do is we can say that the volume of the cylinder in terms of R is going to be equal to pi times the radius squared times the height, so the area of the base times the height. When we know that the height is equal to twice the value of the radius, we can substitute that into the actual volume formula here for the volume of the cylinder. So we go back to having pi times the radius squared times the height, which is 2 times R. Okay. The next step here is to simplify. And so we end up with pi times 2 times the radius to the third power. Now, we notice that something has changed, and you said the third power. How is that possible? Well, if we have R times R, and then we're multiplying by R again, that would be 3 times that value. When we find the value, the total volume, we end up with 2 times R to the third power times pi. The next step is when we find the volume here of the cone, we end up taking 1/3 of the total volume of the cylinder. So again, 1/3 of 2 times the radius cubed times pi. Forgot to put units on this one. And then this one translates down to 2/3. So 1/3 of 2 is 2/3 times the radius to the third power times pi. Now when we get into the volume of a sphere, remember that the volume of the sphere is going to be 2/3 the volume of, back to here to the volume of the cone. So that volume of the cone, so the volume of the cone is going to be 2/3 the total volume of the cylinder. Sorry for that interruption, which would be multiplied by 2 times the radius to the third power times pi, which makes it in effect the volume of cone is always going to be 4/3 the radius to the third power times pi. The way that we read this then, when we talk about the volume of a sphere, this is the major takeaway from this, is that the actual formula for the volume of a sphere is equal to 4/3 times pi times the radius cubed. So it's the exact same work that we just did to figure out how to go from unknown values. All we know is that the radius is exactly the same in each of these figures, and the height is exactly the same. By understanding the radius and the height are the same, I can figure out that using the height of the cylinder to find the volume of the cylinder, and then finding the volume of the cone and recognize the relationship of these two, that this one of the sphere is 2/3 the volume of a sphere, the same height and radius, ends up telling me that the volume of the sphere and the volume formula for a sphere is 4/3 times pi times the radius to the third power. So now when we talk about a volume of a cone is 1/3 the volume of a cylinder, the volume of the sphere is what fraction of the volume of the cylinder. And when we look at this, here's the volume of the cylinder that we just came up with right here. The volume of the cylinder is 4/3 the total volume of a sphere. So when we talk about the cylinder volume of a cylinder is 4/3 the volume of a sphere. Okay, so we talked about how the volume of this cylinder is 2/3 this volume. So the reciprocal of that, or the multiplicative inverse, is going to be that when I go to find the volume of the cylinder, I could take the total volume of this sphere and multiply it by 4/3 to get that volume of the cylinder. So interesting facts, interesting ways to recognize that they all are related in their volumes. Okay, that does it for our lesson. The whole point of today's lesson was to discover the volume formula for a sphere. So think about a sphere with the radius of our units that fits snugly inside that cylinder. The cylinder must also have the exact same radius and a height that's twice as tall as the radius. Using what we've learned about volume, a cylinder has a volume of pi times the radius squared times the height. So we can rewrite that as pi times the radius times r squared times the height of 2r, because the radius is twice the height in this situation, which is equal to 2 times pi times r to the 3rd power. You notice that this is written just slightly different from what I had up above, which is no problem. It's simply because I changed the order of the way that it was written. You can do that in multiplication. We know in earlier lessons, the volume of the cone with the same base and height as a cylinder is 1/3 the volume of that cylinder. And so we recognize that piece about how to find that volume of the cylinder. And then we go to the related sphere, and we recognize that if we fill up that cone of sphere with water and then pour them out, we find out that that cylinder would be would pour out the volume of the cylinder plus, oh my goodness, the cone plus the cylinder. If we were to fill these two up, they would equal that total volume of the cylinder. So thinking about this is 1/3 the volume of that one. This is 2/3 the volume of that one. So together it makes 3/3 that volume, or the entire volume. Bottom line is this. If we talk about the formula for the volume of a sphere, this is what you really need from today's lesson, is to know how to find the volume of a sphere. Thanks for checking in. Sorry, my voice is still a little crackly. I'm glad to be back to recording. Hopefully you're doing well. Let me know what I can do to help you out. You guys are doing awesome. Take care.